about the basics of an ellipse. It's another type of conic section. It has an H and a K as its center. Of course, you can look at these and these are oblong, they're oval. They either are oblong, they're long vertically or horizontally. And vertically would go along with the y-axis because the y-axis is vertical, it's up and down on a coordinate plane. And horizontally would be the x-axis because that is what is horizontal on the coordinate plane. So here's our coordinate plane. This is your y-axis, this is your x-axis. So it makes sense when I say horizontal with the x-axis, it's pulled along the x. Vertical with the y-axis, it's pulled along the y. So there's two basic formulas, and it just depends on whether or not it is a vertical elongated ellipse or horizontal. Let's start with the horizontal, which goes with the x-axis. Its formula is x minus h squared over a squared plus y minus k squared over b squared equals 1. A squared is the larger denominator, b squared is the smaller one. So when you have these equations, the first thing you want to identify is where the larger denominator is. And that's what determines whether or not it is stretched horizontally or vertically. The larger denominator is with my x. And since it's with my x, it is stretched along the x-axis, which is horizontal left to right. Okay? And so this formula is pretty much the same. The only thing different is that now the larger denominator is going to be underneath the y, which makes sense because y is vertical. So it's going to stretch vertically. So its formula is x minus h squared over b squared plus y minus k squared over a squared equals 1. And the other really important thing is that you need to notice that they have to be equal to 1. If they're not equal to 1, then we'll have to fix that. Okay, so inside the ellipse, it has a center, and we determine the center by HK. H is the number being subtracted from x. Remember, x is always the first position in an ordered pair, so h goes with x. And the k is the number being subtracted from the y. And so this is my first number, which goes with x, and my second number, which goes with y. So what's subtracted from x and what's subtracted from y? Length of the major axis, that's really important. Major means bigger in math. And so the major axis would be the longest distance through the center of the circle from, or not circle, ellipse from edge to edge. So in this case, the major axis is vertical. In this one, the major axis is horizontal. Okay, so the major axis is going to be 2 times a. Well, a squared is the bigger denominator. And so what I have to do is take the square root of this denominator so I can figure out what a is. And then I'm going to multiply it by 2. That is the distance from this furthest point to this point, or this point to this point. Okay? And if you know that, that whole distance is 2a, and that means this is a, and this is a, and a plus a is 2a. And this distance is a, and this distance is a, and a plus a is 2a. And we'll use some numbers in a minute with that. All right, so the major axis is the long axis. It goes with the bigger denominator. The length of the minor axis, that's the short distance from edge to edge through the center. That was terrible. And the minor axis is determined by the smaller denominator. So the minor axis is 2b. So I'm going to take the square root of the smaller denominator and multiply it by 2, and that gives me this distance, the shorter distance through the center. Then we have a foci just like your circles do and your parabola. And it always is along the major axis, by the way. So there's two formulas And it's determined, which formula is determined by if it's the horizontal ellipse or the vertical ellipse. And it goes along with the major axis. So in this case, my major axis was determined underneath the x. In this one, my major axis was determined underneath the y. So you have to find the bigger denominator to find your foci. And the first thing you have to solve for is c, because c is part of the formula in the foci. And so c squared is a squared minus b squared. So the bigger denominator minus the smaller denominator is c squared. So then I would take the square root of that to find c. Okay, if my major axis is horizontal, so my bigger denominator is under the x, then my foci is going to, my letter C, my foci is going to be along my major axis, but it is going to affect the h because the bigger denominator is where the h is. So that is where my foci is going to be. So if it is my larger denominator is under x, then my foci is going to be h plus and minus c and k. So my h is affected if my bigger denominator is underneath where h is. Okay, so that's a huge connection there. But if my bigger denominator is under my y, where my k is, then my k is affected and not my h. So then my foci would be h. It would not be affected. Who's affected? My k, because my bigger denominator is under my k. So it would be k plus or minus c. Okay, let's try a couple problems that are already ready. They are already equal to 1. We have, it's already solved for, it's in ellipse form. And I'm going to find my center, which is hk. My length of my major axis is 2a. The length of my minor axis is 2b. C is found by using the formula c squared equals a squared minus b squared. And then my foci, well, it's going to be determined by where my bigger denominator is. So the first thing that I really want to do after I make sure it is in ellipse form, and it is I want to find my bigger denominator. Well, here it is. It's underneath my x. Now remember, this is your x-axis, so it's going to be ellipse, stretched along the x-axis, so it's going to be elongated this direction, left and right, horizontally. So that means my foci is affecting the h, because my h comes from my x. So I know the foci's formula is going to be h plus and minus c, and then k. All right, so I want to determine all of these things, and then I'll fill them in, and I'll graph them as I go. All right, so let's start with the center. Okay, my center is determined by hk. H is the number being subtracted from x, and so what's being subtracted from x is 0. My k is what is being subtracted from my y. Well, what's being subtracted from y? Well, nothing. So my k is 0. So the center of this ellipse is 0, because that's my h, and 0 because that's my k. So the center is at 0, 0. I'm going to go ahead and put my center on here. Next, I need to determine the length of my major axis. Well, where's my major axis? Here. That's where it's determined because that's my bigger denominator. So my major axis is going along the x-axis or parallel to the x-axis if it's not the x-axis. So I need to figure out A. A is the square root of this denominator, so A is 6. The major axis is 2 times A. So the major axis is 12. That's how long, how many units it is all the way from left to right. My major axis is 12 units. Well, if this is the center, I'm not going 12 units on that side of the center. The center is in the middle of 12. So that means I'm going to go 6 units to the right and 6 units to the left because the major axis, this is the center of the major axis, and the major axis is 12 units long. So let's put the points on there. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So that's the length of my major axis. My minor axis is 2b. That is, first I've got to find b. b is the square root of the smaller denominator, so b is 5. And 2 times 5 is 10. By the way, these are almost the same distance, almost a circle, but not quite. All right, so the length of my minor axis is 10. Well, here's the center, and the center of 10 would mean there's 5 above it and 5 below it. So let's put those points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we'll connect. It's terrible, but there's my ellipse. It's a little bit longer left to right than it is up and down. All right, C. I have to find C so that I can find where the foci is. And I'm going to use the formula a squared minus b squared, where a squared is 36 and b squared is 25. So c squared equals 36 minus 25. So c squared equals 11. So c equals the square root of 11. Now, my foci is always on my major axis. My major axis is this direction. It's right here. So it's where my x is, and x right here. So it affects my center, the h of my center, the x of my center. So my foci, I'm using this formula, so it's 0 plus or minus the square root of 11, and then k stays the same, so it's 0. So the foci is at plus or minus the square root of 11 and 0. Okay, here we have an ellipse, and it's already ready to go. It's equal to 1, and it's good. It's in good form. So I want to determine all my critical points, and I want to graph it. And so let's start out with determining what everything is. Remember, my center is h, k, and so I want to figure out what h and k are. H is the number being subtracted from x, because h is in the x position. So it's the number subtracted from x. So h is positive 1. K, which is in the second position, the y position, is the number being subtracted from the y. So k is negative 3. All right, so my center is at 1, negative 3. So I'll put that on my graph. 1, negative 3. There's the center of my ellipse. Now, I want to go ahead and determine where my bigger denominator is, because that's the direction of my major axis. It's going to determine who my A and my B are, and it also is going to determine where my foci is. So here's my bigger denominator. It's with the y. Since it's with the y, by the way, that needs to be squared right there. Since it's with the y, it is going to be stretched vertically with the y-axis, okay? So I know that A is the square root of 16, so it is 4. B is the square root of 4, so it is 2. And I know my major axis length is 2A. My minor axis length is 2B. I know to find C, I'm going to do C squared equals A squared minus B squared. And my foci goes where my major axis is. It affects my major axis. It's right here. It's affecting K. So it's affecting this negative 3. So my formula is going to be H and then K plus or minus C. It's affecting my K because that's where my major axis is. So you're going to add or subtract C depending on where your bigger denominator is. Wherever your bigger denominator is, that's who you're adding and subtracting C from the center. Okay, that's a really easy, if you think about it, that's a really easy concept to remember. Okay, major axis is 2A. My major axis was 16. The square root of 16 was 4. 2 times 4 is 8. That's how long my major axis is. Remember, it's going this way. From the center of 8 is 4. So I'm going to count 4 above the center and 4 below the center. There's my major axis. My minor axis is 2b, so my minor axis is 2 times 2, which is 4. So from the center, I'm going to go 2 to the right and 2 to the left, because the center of 4 would be 2. Whoops. And then I'm going to connect those the best I can. And you can tell it's elongated vertically along the y-axis. That's the length. Okay, so my C, I'm going to use this formula. So C squared equals A squared, which is 16, minus B squared, which is 4. So C squared equals 12. C equals the square root of 12. So C equals 2 square roots of 3. So my C is always adding and subtracting from wherever my major axis is, right here. So I'm adding and subtracting from the -3, because that's where my major axis is. So my foci is going to be 1, because the 1 didn't change. And then my -3 plus or minus 2 square roots of 3.